Hello, my name is Carol Hakim Hambili. I am from DEE2C. So today I will present about generic scale 2. Chapter 3, Bipolar Junction Transistor BJT. Practical work 4. So our objective for this practical work is able to apply the principle and operation of BJT to basic transistor common emitter configuration, able to construct the CE circuit by using multimeter to measure voltage and current in the circuit. Next one, our learning outcome for this practical work is first, able to recognize the type and terminal of BJT via datasheet. Second, construct the circuit of CE configuration. Third, able to measure voltage and current in the circuit by using multimeter. The last one is able to determine the value of beta of the transistor. So this is our important formula. So we know is IE equal to IB plus IC. IB is normally approaching 0 compared to IC. So we can assume that emitter current is approximately similar with collector current IC. So it means IC approximately with IE. So the current value little bit same. So for the beta is IB equal to IC per IB. Okay, B beta equal to IC per IB. So this is our procedure for this particular work. First of all, connect the circuit as shown in figure 4.1 by using the given component. So first of all, from the power supply, connect to the RC, which is 180 ohm. So the next resistor is connect to the B, which is RB 820 kilo ohm. So we will get like this. So the earth terminal, which is emitter, go to the negative power supply. So this is a diagram which is to show you guys how to search the IC and the voltage. So next one is initial power supply setting set to 10 volt, which so this is we set to 10 volt, but this diagram we do the 20 volt because the next part is use 20 volt and 10 volt. And next one is by using the digital multimeter, search for IB like this, same to the goes with IC and IE like this. So we will adjust this. First of all we need to open the circuit and connect the positive probe to the positive current, and the black probe to the negative current, which is it will close the load. Next one, search for VRB, which is like this. You use the voltage, VRC, VCE. So we will record the value in table 4.1. So same goes to the 20 volt. We make the same like this, but we just adjust the volt, adjust supply, power supply, this one. So next one is switch off the power supply after completing the experiment. Double check all components are safely powered down before disassembling the circuit. Next one is the result. So in this practical work, for the IB 10 volt, we got 11.4 micro. For the 20 volt, 23.7 micro. For the IC 10 volt, 3.86 milli. For the 20 volt, for the next one is IE for 10 volt, 3.87 milli. So the value, the theory that we know is the same. IC and IE are approximate, so lebih kurang sama, jadi teori itu benar dan kita dapat menjelaskan teori tersebut. Seperti yang kita tahu, 8.4 dan 8.42 tidak jauh beza. So for the voltage, we got for 10 volt, we got 9.5 volt, 19.7 volt, VBE 0.6 volt, 0.6 volt, 10 volt, 2.6 volt, 6.3 volt, 7.5 volt, and 14.2 volt. So in this practical work, we also need a safety. So our safety precaution is check the connection before the power up. So we need to determine the circuit is properly connected to avoid short circuit or incorrect current flow, which could damage component for the multimeter. If you make the wrong circuit, the fuse multimeter will burn. Next one is use proper voltage range. Never exceed the specific power supply limit 10 volt and 20 volt in this experiment. So you need to use volt yang sesuai. So next one, handle multimeter properly. Set the correct mode, current or voltage on the multimeter before connecting it to the circuit to avoid damaging the meter or getting incorrect readings. Next one, avoid touching live wire. When the power supply is on, avoid touching any part of the live circuit to prevent electric shock. Next one, disconnect power when changing circuit. Always turn off the power supply before making change to the circuit or increasing voltage to prevent sudden surge or damage. Use proper tools and components. Ensure all resistor and transistor are within the right limit. Use the correct tools. No bare hands or metal object to adjust connection. So for the question 1, calculate the value of beta BCD for transistor when the supply voltage is 10 and 20 volt. So we know that from the theory we got B beta equal to IC IB. So for the 10 volt, from the result we get IC equal to 3.86 milli per IB 11.4 micro. So equal, we get 338.6. So for the next one is 20 volt. We make B equal to, this is beta, equal to 8.4. We got this value from the from this result that we get. Per 23.7 micro. This is milli. We got beta equal to 354.43. So for the next question is question 2. What can you observe from the table 4.1 when the power supply is increased? So we know when the power supply is increased from 10 volt to 20 volt, the collector current, emitter current, and collector emitter voltage VCE generally increase. This is because the higher VCC product provides a greater potential difference, enabling more current to flow through the transistor. As a result, voltage drop across the resistor VRB and VRC also increase slightly due to the higher current. The transistor continues to operate in the active region provided it does not enter saturation or cut off. So which is mean from this we know 10 volt we got a lower result to compare to 20 volt we got the higher. So here VRB we got about 10 volt different, and same goes to the others. Got a big difference when we increase the power supply. So for the conclusion from this experiment, I have learned how a bipolar junction transistor BJT operates in a common emitter VCE configuration, and how change in supply voltage affect transistor behavior. The result clearly support the theory. As the power supply voltage increase, both the collector current IC and collector emitter voltage VCE increase, which is consistent with the transistor current and amplification characteristic. The experiment also demonstrates the close relationship between base current IB and the collector current IC, helping to calculate the current gain beta accurately at different voltage. All measurements align with theoretical expectation, reinforcing the understanding of transistor behavior in active mode. Possible source of error may include inaccurate multimeter reading, component tolerance, and contact issue on the breadboard. Despite this, the results were consistent enough to validate the theory and objective of the experiment. Overall, in this practical has deepened my understanding of BJT operation and improved my skill in circuit construction, measurement, and analysis. So that's all from me. Thank you.